This is Chapter 14 of Learning Web Design, which covers padding, borders, margins, and other features of the CSS box model. Every element within the body of an HTML document has an invisible box around it that's used to provide white space and a border. The interior of the box is the content area, which is just whatever markup is inside the element within the HTML. Surrounding the content area is a layer of padding, which provides white space between the content and the element border. On the outside of the border is the margin, which provides even more space to keep the element from bumping into things. Here's an example that styles each part of the element box. The content area is 6 ems wide, with the height automatically stretching to contain whatever is inside. The padding is 0.25 ems all around, providing some space between the content and the dotted border. The background color of an element lies underneath the content, padding, and border. That's why the spaces between the dots and the border are orange. The content is set to 1 em, which you can see as space around the outside of the border. Without margin, the letters would be touching the border. Finally, the display of the box is inline block, which tells the browser to honor the margin setting, but to otherwise treat it like an inline element, as if it were a character within the text. The size of the margin, padding, and border can be specified using ems, pixels, and the other standard units we discussed in Chapter 12. In fact, we can specify each side of the box separately. For example, we could apply more margin above and below an element than on left and right. That gives us at least 12 different settings, but that's not all. We can also, of course, specify the height and width of the content area as well. All of this flexibility makes it a little confusing to say that the actual height and width of the element is whatever we set. Does it include the margin, the border, the padding? As it turns out, CSS3 supports 2 different ways to specify the height and width of the box. The first and original way is the CSS1 box model, in which the height and width settings are considered to be for the content area only. The rest of the measures are added in after the setting aside for allotted space for the content. The second way is with the new CSS3 border box model, which attempts to simplify the width calculations by treating the element border as the official edge of the box. In the CSS1 content box model, all width and height properties in the CSS refer to just the height and width of the content area, or as it's called here, the content box. The total width of the element is then calculated by adding the margin, border thickness, and padding to whatever is the specified width. Starting from the left side, the total width includes the left margin, the left border, the left padding, the given element width, the right padding, the right border, and the right margin. This example shows the CSS for an element whose given width is 600 pixels. It has 4 pixels of padding on the left and 3 pixels of padding on the right. There is a 1 pixel border and a 5 pixel margin all around. The total element width then includes 5 pixels left margin, plus 1 pixel left border, plus 3 pixels left padding, plus 600 pixels content box width, plus 4 pixels right padding, plus 1 pixel right border, plus 5 pixels right margin. That works out to 619 pixels in total. So, even though the designer specified that the width be 600 pixels, the element actually takes up 619 pixels on the page. In CSS3's border box model, the height and width specify the border box, which includes everything inside the outer edge of the border. The effect is that the width of the content area is the specified box minus the border and padding. It is possible with this model to squeeze out the content entirely if the padding and border are too thick. On the plus side, it does simplify the total element width calculation, which is now just the box width plus the margins. To use the border box model, one has to use the box sizing property. The default value for box sizing is to use the content box model. If we don't specify a box sizing, then we always get the content box sizing. By setting it to border box, the height and width settings control the width of the border box instead of the content area. If we have a box with width 600 pixels, 3 pixels padding all around, 5 pixels margin all around, and a 1 pixel border, then the content box is 600 pixels minus 3 pixels of left padding minus 3 pixels of right padding minus 1 pixel left border minus 1 pixel right border, which leaves us at 592 pixels. The overall element width is then 600 pixels plus 5 pixels left margin plus 5 pixels right margin, which works out to 610 pixels in total. The reasons for introducing the border box model in CSS3 actually go back to the first box model standard in CSS1. Many designers back then, and even the programmers who wrote Internet Explorer 5 for the Macintosh, seemed to assume that the box model used the border box sizing method. It was just more intuitive than the content box model. Using visual design of a web page, we tend to go with a wireframe like the one on the right, with rectangular regions representing content of one kind or another. In such a sketch, there is no convenient way to show the content box outlines. They're actually invisible on the page. You'd have to pencil them in, maybe with a thin dotted line or red extension lines, knowing that they would not appear in the final page. With the border box model, however, the dimensions of the box are often readily visible as the outer edge of the border around the content and padding. Again, this is more like how many people think of page layout anyway. The trade-off is that the content area will shrink or grow with changes in the border thickness and padding. But many designers find that preferable to not being able to see the box dimensions at all. This example from the book shows the differences between the two models. The box on the top uses the border box model, where box dimensions can be measured directly by looking for the outer edge of the background. The content box on the bottom, on the other hand, has padding and border outside the specified box dimensions, making it hard to visualize the box without adding the extension lines on the corners. One thing that often trips up new web developers is that height is often treated as a dependent variable that changes depending on the element width and the contents of the box. Basically, since having a fixed height and a fixed width runs the risk of leaving us with not enough room for the content, we generally specify the width and then let the height grow to fit the content. Besides this somewhat intuitive reason for not specifying a height, there is also the issue of dealing with all of the arcane rules for total element height. Confusingly, inline elements don't have top or bottom margins. Even more perplexing are the collapsing margin rules for block elements. We'll have more to say about those things in a few minutes. So, given all of that, the general consensus is that it's best not to depend on having precise control over box heights. Instead, let them auto-scale to fit the content. While letting the height or width vary with the content works just fine most of the time, there are limits on how big a box can expand to fit the content. When that happens, we've only really got 3 options. We could adjust the size of the content itself by shrinking the text, images, etc. We could force the box dimensions to enlarge, even if it means crowding out or obscuring other content. Or we could use the overflow property to clip the content so that it displays as much as it can without spilling over the box. The overflow property allows the designer to control how content that otherwise would not fit in the box is handled. The visible setting allows the content to spill over the bottom of the box, even if it then obscures other content. The hidden setting clips the content so that it fits, even if that means that some content is lost. The scroll setting adds a scroll bar, which is often pretty ugly, but at least all of the element content is visible. The auto and inherit settings defer the choice of visible versus hidden versus scroll to either the browser or the parent element, respectively. This example from the book shows each of the settings. Of course, since the auto and inherit settings are somewhat context dependent, only the top three matter for our purposes. Visible causes the content to spill outside the element box. You can see that because of the background not being under some of the text. Hidden clips the content to fit. You can see part of the text hanging out at the bottom there, just barely visible, chopped off. Scroll adds the scroll bar, which might vary in look and feel depending on the browser and the operating system. Most designers try not to use the scroll option unless it's absolutely necessary. When specifying box dimensions, it can be a hassle as well as error-prone to set the sides of each box separately. If, for example, the designer wants the left and right margins to be the same, then the designer would have to enter the same number for each side and then remember to keep them in sync forever after as the design evolves. Directional shorthand alleviates both of these problems at the same time. There are 4 basic forms allowed in the shorthand. If there are 4 values, then the first one is for the top side of the box, followed by the right side, then the bottom, and lastly the left side. We use the mnemonic TROUBLE, or TRBL, to remember the order. If there are 3 values, then the first is always for the top side, the second value for the left and right, and the third is for the bottom side of the box. If there are 2 values, then the first value is for the top and bottom, while the second value is for the left and right. Finally, if there is only 1 value, then it applies to all 4 sides of the box. These examples show each of the forms being used for a single element. The padding is specified separately on all 4 sides, following the TRBL pattern. The margin declaration uses 3 values, with both padding left and padding right set to 6 pixels, while the margin top and margin bottom are set to 3 and 5 pixels, respectively. The border style property is using a solid border on top and bottom and a dotted border on the left and right. The last declaration sets the border widths to 2 pixels on the same on all 4 sides. While it may seem like a bother to use the directional shorthand, learning to use it properly is well worth the effort. It will eliminate bugs and reduce the number of declarations in the style sheet, making your pages load faster. Since each part of the box model has its quirks, we'll deal with padding, border, and margin separately. Padding is reasonably straightforward, with most of the usual design tips suggesting things that make a lot of sense if you stop and think about them. First off, since larger font sizes look better with more padding than the padding with smaller font sizes, many designers use M's to specify the padding. This will cause the padding to scale with the font size. The next tip is less intuitive. When working with inline elements, larger line height can sometimes cause apparent top and bottom padding to grow. The padding itself isn't growing. Line height works inside the content area, not the padding, but it nonetheless will appear to be so if the line height is larger than the top and bottom padding. Finally, if you're working with the border box model, then take care that the padding doesn't squeeze the content area down to nothing. For borders, you can specify a lot more than just their width. Further, there is even a shorthand to combine the various border properties into one declaration. Like all CSS shorthand, the order of the values matters. If you're setting a border style and find that the browser is ignoring your shorthand, then make sure you are getting the order right. 2 pixels dotted red is not the same thing as red 2 pixels dotted. The first will work, while the second will just get ignored by your browser. Border radius is a new property in CSS3. It allows you to specify rounded corners or even a completely circular shape. The property cannot be combined with the other border properties because it has its own shorthand notation. Finally, take care to include the border thickness and element box dimensions. When using the content box model, the border makes the total element box bigger. When using the border box model, it squeezes the content box just like padding does. The tips for margins are somewhat more complex than for padding or borders. The first tip has to do with collapsing margins, which we mentioned a few minutes ago. If 2 elements are stacked one above the other, then the margin between them collapses to the largest of the margin top of the lower element and the margin bottom of the upper element. It's best understood with a visual example. Here we see 2 block elements, one after the other. The upper one has 4 ems of margin on bottom, while the lower one has 2 ems of margin on top. Instead of having 2 plus 4 equals 6 ems margin between the 2 boxes, the browser will collapse the margin to 4 ems, which is the maximum of the 2. The second tip is that margins work differently depending on the element type. Block elements have margins on all 4 sides. You can specify margins for an inline element, but only the left and right margins have any effect. Inline block elements, like images, work like inline elements, except that they have functional top and bottom margins. This example from the book shows the difference between inline elements and inline block elements. Inline elements work like text within a paragraph, which can have padding on either left or right, but the spacing between lines is specified by the line height property. Inline block elements can have margins all the way around. This is so that images are not crowded by the text flowing around them. The third tip is about negative margins. The effect of a negative margin is to slide the element over in the direction of the negative margin. This can be used to cause elements to overlap, which was a neat trick back in 1998, but it's pretty ho-hum today. This example from the book shows negative margin being used to overlap paragraph text, while positive margin causes the paragraphs to separate. Negative margin causes them to move closer and ultimately to overlap. The last margin tip is the use of auto margin to center content within its container. Setting the margin to auto will allow the margin to fill all available space. When both left and right margins are done this way, the effect is to push the element to the center. And no, this one is not in the book. All of this talk of inline versus inline block leads us to the display property, which can be used to alter which layout rules apply to the element when rendering the page. This allows us, for example, to cause an image to appear on a new line just by changing its display from inline block to block. While we've already discussed inline block and inline block displays, there are actually a bunch of other layouts. The textbook has a complete list of them all, most of which are used to simulate old-style table layouts without actually using tables in the HTML. As we wind down the chapter, the next topic is the box shadow property, which is a lot like the text shadow property covered in Chapter 12. A box shadow works just outside the border and has no effect on the element box dimensions. Here we see a box shadow used to bring attention to an announcement on the business plan competition website. The effect makes it look like the message sits above the rest of the page. It is the only place on the page where a box shadow is being applied. The last topic is the use of vendor prefixes to target specific browsers. Each of the major browsers has a standard prefix. Moz for Mozilla, that would be Firefox, WebKit for Safari and formerly Chrome, O for Opera, and MS for Microsoft. If you want to set a property differently for one browser than for another, just prefix the property name accordingly. Here's an example that applies a border radius to round the corners of an element. The first declaration works just in old versions of Firefox. The next four work in old versions of Safari, while the last one, without the prefix, will work in any modern browser that can understand it. Typically, you see prefixes used in this way for newer CSS properties that are not yet 100% supported by all browsers. As indicated in the comments, that's exactly what is happening in this case. The unprefixed version doesn't work in Firefox 3.5, but the prefixed one does. Similarly, in Safari 5, there was a bug in which it did not understand the border radius shorthand, so 4 prefix declarations are used instead. Most of the time, the last declaration, without the prefix and using the shorthand, is the one that the browser will follow. Modern browsers handle border radius just fine without the prefixes. With that, we're done with the box model, for now anyway. Thank you for following along with Chapter 14 of Learning Web Design. See you later.